Okay, so if you look at, we can even extend it to 3 boxes later. So if you look at what here Aram has done, he's figured out that he's always subtracting this number from this number. So 30 minus 15. Uh, and then he's working it out, that's 15. And then he says, okay, 3D stays as it is. And this has become 15. And then D has become 5. So again, the division, since it's simple enough, is being done in the head, right? So you can continue with doing with 2s, and you can then do it with 3s. Then the question is, how do you introduce negative numbers, which also comes, right? So of course you remind them about integers, right? And for integers we'll make another video in which they can also have some sort of a Sanskrit sloka. That's how it was taught in the time of Brahmagupta. So you can even introduce history that integers actually first started in India, and then they went to were misinterpreted partly because they couldn't understand negative numbers. So the negative numbers were dropped and so on. So we can have that whole story about integers. But once you've done integers, you can start introducing that into the linear equation, which we'll look at now. So then if you have used the tokens before, with this being negative and this being positive, then you can say that, okay, similar to that, there are 2 boxes, they have the same number of tokens, they can be either positive or negative, and those tokens plus another 15 tokens is equal to 5 tokens. So in that case, the children can work out so I've just written it down, 2 boxes. Basically this represents the number of tokens in the box. Let's remember that. So 2 of what's in the boxes plus 15 tokens gave me 5 tokens. So now if I solve it, so we are saying that there were 5 tokens and we want to remove 15 such tokens from it. So this part they have already done, and you can remind them it's a smaller positive number minus a larger negative number. So it is a difference when both the signs are not the same. Then it's a difference of the 2 and the sign of the larger number. So in this case, the result will be negative 10. This is a number, it's not a symbol. So 2 boxes are negative 10. So 1 box will have half of that. Negative 5. If you really want to use different colors for positive and negative numbers, if you've done that in the past, then you can use the 3rd color, another color, 4th color in order to do that. But this I think children should be able to figure out. You need to add 10 zeros, so there will be the 10 positives that will go away and 10 negatives will be left. Okay, so then of course they can check the result by opening the boxes and looking at it. And I think the other thing to do is to basically introduce that you can check your answer. Let's say you've got a result of negative 5. Then you don't need to go and ask someone if your answer is correct or not. You can figure it out yourself. You know that 2 what's in the boxes plus 15 is 5. So you just substitute. So you say, okay, now everything is known. So I have 2 times negative 5, or I should have put times. 2 times negative 5 plus 15. So let's find out what this is. So 2 times negative 5 gives me negative 10. Negative 10 plus 15 gives me 5. And you can introduce that this is called left hand side. And you are going to check if this is basically equal to the right hand side, which it is. So that means the result that you have got is also correct. You don't have to go and ask anyone if the result is correct. So checking the answer can be also introduced when you're doing linear equation in one variable, and then extended to when you're doing linear equation in one variable with negative numbers. So you can work out quite a few questions as practice, right? So, and by this time I also introduced that you can just give it a name. I chose different names, but they didn't appeal to him. So D he thought could not be confused with the box, so he put D. Otherwise, if they're okay, you can use B, you can use X, you can even introduce why we are using X. That's up to you. But as long as they are putting a letter which cannot be confused with a number, and then accordingly they're using a different color, I think that should be okay. It makes them conscious enough about what they are doing. So you can mix up the question. There can be questions that have negative on this side, negative on both sides, and so on. So that there is enough practice for different kinds of questions that you would get when you have a single variable. I would stick with 2 and 3 because all the children will not have a difficulty with dividing with 2 and 3, and the difficulty will not be there. So once they are all confident with it, then you can give any kind of equation with any coefficient of the variable also.